assignments. Assignments are done. Some of you might be happy with it. Not. So we're really going to dive into the project in this section of the course. So the next kind of 2 weeks are going to be one half of the project, and then the weeks after that will be the second half of the project. So if you have computers, you should check out the robust traffic light starter. So that's going to be the lecture lab from Friday. So we're going to go over the first two questions in that lecture lab. And then the second thing you should check out is the Sax Parser Example. So this example will demonstrate how to parse XML in an event-driven manner. And so we're going to go over that because that's going to be basically the first half of the project will involve doing a lot of parsing. And so you'll need to figure that out. So thank you for doing the evaluations last time. Those were super helpful. So it seems like people seem to like assignments a lot and doing a lot of programming. So I think you're in luck if you're into that because the project is going to be really intense. There's going to be a lot of programming in the project. So if you like programming, that's going to be awesome. Some of you like labs a lot, which is fantastic. I'll try to be slower in Eclipse when we're in lecture. And also I wanted to mention that, if you really want more help, if your DLC hours are not working for you or your labs are not working for you, you can send me an email and just meet with me, right? So I have office hours, which is just 1 hour a day. But if you want to actually meet more with me and see me, if you ask any questions, just send me an email. And we can arrange it. So this week in lab, you're going to be marked for lab 5. You really need to have a project partner. So the project is a lot of work. It's pretty challenging. And your partner is your first go-to person to ask for help and to kind of coordinate with. Second of all, in the phase 2 of the project, you need your partner because you'll be presenting with them. And so your mark will in part depend on the person that you choose. Choose wisely. And in phase 1, you get to work together, but you get to submit your code individually to the webcat server. So we'll go over that in just a little bit. So project partners, that's important. You should have that done. Phase 1 of the project, so as I said, it's going to be 2 weeks long. So you'll have quite a bit of time to actually do phase 1. But as you probably learned with the assignments, you can't really start on them the day before. Right? So make sure that you're working the entire time. Because you're not going to have assignments due. So you have a little bit more time to work on the project. Assignment number 5 is due tonight at midnight. I hope you guys started. There were a lot of great questions on Piazza, so keep asking them. There'll be no more assignments. And then all the readings and exercises have been posted. They're online. So what are we doing today? So we had that lecture lab on Friday, the exceptions lecture lab. I didn't really have a chance to go over it, so I'll go over 2 of the questions in the lecture lab. Now I'll give you sort of an overview of the project. It's pretty exciting. It's like an Android application, so it's going to be hip, and if you have an Android application, Android phone, you can run it on your phone. It's very cool. And then we'll talk about kind of the thing. So a lot of this week we're going to be covering topics that you need for phase 1 of the project. And so, at least half of that is going to have to do with parsing, XML parsing. So we'll start with that today. And then on Wednesday we're going to talk about OO design, which is another piece that you need for phase 1 of the project. Great. So let's go back to this to the lecture lab from Friday. In case you can't remember, the lecture lab is based around the robust traffic light starter project. And this was supposed to demonstrate exceptions and exceptional control flows. So here's the first question, and it has to do with assertions. So if you here's my robust traffic light starter. I have a traffic light. The traffic light knows about its current light color, and it knows about the last color that it had. And we have this method that we were using to demonstrate invariance. So you can call hasValidState on the traffic light. And hasValidState will actually check all of the invariants that we declared at the top of the project. Right? And it will assert these invariants. So then there's also calls to get the color of the traffic light, to reset it and advance the color one extra step, and then set the color. I think that's it. So this is what you start out with. And then for task 1, you're supposed to look at the traffic light tests, and especially take a note of this test. Test things that I'd rather not be able to do. So here's a test. I'm setting my traffic light color to blue. I'm making sure that it's set to blue, right? And I shouldn't be able to change the color, so I set the color to green, set it to red. I do some other things. But if I run this test, and I just run it as JUnit, then all my tests will pass, including this one. So the thing I'd rather not happen, happens. Right? So instead of failing, this test passes. So that's an issue. And why does it pass? Okay, no, why it's passing. So I have this invariant, right? Didn't I define this thing that has valid state, that my color is either red or green or, all these things? Yeah.
Are assertions enabled yet?
Yeah, the assertions are not enabled, right? So remember, assertions are these runtime checks, and they can be either enabled or disabled. And by default, they're disabled. So if I run the test, everything works. It's great. But it works because this assert is actually not triggered. When I run the program, this statement is not evaluated. So I need to tell Eclipse that I actually want assertions. So for that, as before, we have to go into debug configurations or run configuration, depending on whether you're debugging or running. And then here, for my traffic light test, I'm going to add a VM argument. So I go to arguments, VM arguments, and add -EA. So this tells Eclipse to enable assertions when it runs those tests. So now if I rerun this thing, I get the thing that I should not be able to do actually failing. Right? So simple demo of what you need to be able to do to get assertions to work, because you need to enable them. Right? That's like point number 1. Questions about what I just did? Pretty clear? So that's like this is question 2A through D, right? So once you enable assertions, they no longer pass, and they shouldn't be passing. The one test that's failing shouldn't be passing because I'm setting color to an invalid color. Okay, so then the second question talks about improving robustness of traffic light. So robustness, robustness is like a keyword. When robustness comes up, think exceptions, think error handling, think testing different corner cases, right? Because that's what we've been going over. So, the first step is, well, look at the exceptions that we've already defined in the package. Okay, so let's look at them. So there's 3 exceptions. This is the traffic light exception, extends exception. There's nothing in it really, just kind of a very generic exception. There's a sequence exception, which extends traffic light exception, also very generic. And then there's a color exception. Color exception is a little bit more interesting. It takes a color, and then the error string that it creates is actually a legal color for traffic light plus color. Right, so the exception hierarchy that we have here is we have exception, and then we have traffic light exception, which subclasses this thing. And then this guy is actually subclassed by two more exceptions. Right, so it extends So color exception extends it, and then also the sequence exception. Right, so this is the exception hierarchy. And so it's telling us, well, now we want to write a specification of set colors that is more robust than the version that's already provided. So if you look in traffic light, and you look at set color, so here's the spec. It's pretty long, right? It's supposedly covers all these conditions. What happens when you're in the red state and you want to set the color to green, when you're in the yellow state, you're setting it to red or whatever. So how can I make this more robust? Considering that we've just talked about exceptions and exception hierarchy.
You gotta throw a color exception and a sequence exception.
Color exception and sequence exception. So when would I throw them?
Once they, you gotta make it if statement.
But this question is about specification, right? So I have to change my spec in order to fit this in. So how would I do it?
You make like two other methods that
So my effects clause changes, right? So the requirement is still the same. They require the same things. Modifies, still this. My effects changes to say something like, if color is given that is not red, green, yellow, then throws color exception. Right? And then the sequence exception is if the color given is wrong color, not in the proper sequence, then throw sequence. Right? Something like this. So first you change the spec, and then you're going to change the code. And that's what C is about. So it says, now you want to modify set color to adhere to the more robust specification. So now our spec includes more things than our implementation, so we have to update our implementation to fit the spec. Right? So, and the hint here is that you could add a new function, is valid color and is in sequence. And those will be your little helper methods. They'll actually evaluate the validity of these things we want to check for. So you could add a public void, what's it called, is valid color. I'll get a string color. So what do I want to do in the body of this one? Look at red, green, or yellow, right? So I'll check my color here. So I'll say if color dot equals red. Well, let's do the opposite, right? If it's not red and my color does not equal yellow and my color does not equal green, then what do I do? Since my helper method is supposed to help me implement this effects clause, so I'm going to throw an exception, right? Throw new color exception. And I have to give it a color, so I'll just give it this color. And I have to import it. And that's it. So now I have this exception. I have to add a throws clause. Throws declaration. And now I need to call it from within set color. So I need to call is valid color. There's no return value, it's a void. I'm just using it to check whether the color is valid. So now I can throw this color exception. Okay, so instead of just putting this code right in here, I just added this check at the top. So that if I need to reuse it later, I can just call this method from somewhere else. Right, so we usually call these things helper methods, and usually we give them private scope. So they're not visible outside of the Okay? So for the second half of the effect, I want to make sure that it's in the proper sequence. So for that, I would write another method, call it isProperSequence, and then it would throw the sequence exception. And it would have a very similar if statement. I'd be basically checking that my current color and the color that you give me is in the right sequence. And if the color you give me is in the wrong sequence, right, it shouldn't follow the current color, then I throw a sequence exception. Yeah?
How long this is where it is valid color? Is it returns true if the color is valid topic otherwise?
Oh, you mean in the exception? Yeah, there's different ways of implementing this. I didn't read the directions. Alright, so so the directions say that it returns a Boolean. So this is one way of implementing it, right? Totally valid. But if I really want to follow the directions, then I would say it actually returns a Boolean value. And so I'll take this away. And I'll say return false. And here I'll return true. So I'll add more Java to check that, oh, if it's not valid, then I'm going to throw this exception. So now I can kill this first. So that's the actual solution, but it's a little bit more verbose, right? But it's also there. Do you guys see that these are equivalent? Right, here I'm not throwing an exception, so I'm just indicating that you got me the wrong color, and then I'll throw it within here, within set color. Whereas the previous code, you threw the exception here, and then it just went up to here, and then out of here. It wasn't handled here, so it came up further. So they're identical in terms of exceptional control. Okay, so do the rest on your own. Ask questions on Piazza. And now, we're going to talk about the project. Okay, so this is the lecture lab. So the project, so we added a new category to the labs and project page. So down below you can see that there's going to be a phase 1 and a phase 2. Right? So phase 1 is going to be due Sunday, which is like 2 weeks from now. So you have a lot of time, but don't wait until Saturday. And the description of the project is here. This is the project overview. So this is all posted. It's very long. You should read all of it very carefully. Sorry. So really, it's kind of like it's a nice, it's very readable. Come on, guys. It's done a lot of work on it. So it just gives you a nice overview of what the project is about, and it also includes phase 1. Right? So you're going to work with a partner. You can also just read the bold things. Those are the most important things. So, key thing to having a successful project experience. So read this one especially carefully. Right? So to do well in the project, you have to make sure to ask questions and work well with your partner. Okay? So it's going to really require more than one person time, hours, to solve this project. So you have to work well together. And then the other thing is that, instead of getting frustrated with some of the issues, make sure that you're not spending more than, say, 45 minutes on like a single task. Right? If it's taking you too long to figure out, what to do with the super constructor, what to pass to the subclass, just post a question on Piazza, send me an email, ask TAs in lab, whatever. So make sure you're using the resources, right? Because it's very easy to get stuck on the project because there's a lot of details and there's a lot of new technology that you'll be using. So we'll try to cover as much stuff as possible in lecture, but it's just a lot of new things, and you're gonna have to be reading new things, right? So there'll be places where you'll get stuck. So what is the project anyway? So let me demo it for you. So here's Waldo. That's the name of the project, Waldo. How many of you know Waldo? Where's Waldo? All right, perfect. We'll get that reference. That's good. So where's Waldo? So you got this little guy, this little person-like thing. This little person thing is you. So your location is plotted on the map. So since this is an emulator, I don't have an actual phone. If I did, I could plug it in and it would actually run on the phone. But as an emulator, I actually have to tell it, things like, where are you located? So in the emulator screen, which you'll get to learn and love very much, you can actually specify your current location. So I could send it my location, right? And that's where this little person figure is placed. So think of the emulator as, it's a virtual phone. It's running on my computer, right? So it's disassociated. So it doesn't know its current GPS coordinates. It doesn't have a microphone. It doesn't have a camera. So if I want to give it those things, I can, right? So I can have it use the camera on my laptop. I can use the microphone on my laptop. Or I can give it a GPS coordinate that's whatever I want it to be. Right? So that's essentially what an emulator looks like. It's executing the same code that a phone would execute, but it's doing it on my laptop. And so a lot of these sensing kind of controls, sensing data I have to actually provide. So this is a little map. The map also plots are the Waldos. So here's some other people on the map. Here's Waldo 1. Very simple. Last seen October 21st. Whoa. It's Waldo from the future. Alright. Waldo 2. Scene 5. Also future Waldo. Okay, great. So 2 Waldos, right? They're plotted on the map. And you can do one more thing with the Waldo. You can get a route to the Waldo. Let's see if this works. So this is actually going to talk to TransLink over the TransLink API. TransLink is like the place that has all, runs all the buses and stuff. And it's going to retrieve the route from the person figure to Waldo. And then it's going to plot it on the map. Sometimes this thing doesn't work. Okay. Let me make sure my design works. It does work. Let's try that again. Maybe hold it. So you're going to be dealing with 2 APIs in this project. There's one web service that we built, which keeps track of locations of people on a map. And so you talk to the service to find out the locations of people. And then they're going to be plotted on your map. Okay, doesn't work. Maybe I could, one thing I could do is actually just restart this. Actually, starting takes a long time, and you'll find out. Because you have to actually boot up your phone on your computer, and that takes a long time. But the way to think about the project is that you're going to have your phone application, and it's running some code. And so your phone application can essentially do 3 things, or a couple of things. Here's my phone. This is Waldo. All right, so one thing I could do is plot my location. So we'll plot a little stick figure, and we'll say this is you. Right, and it says, oh, you're at UBC. Right. And then the second thing you could do is get other Waldos. And so the other Waldos are going to be kind of like dots sprinkled around the city. And the third thing you can do is get a bus to a Waldo. So getting a bus to a Waldo, they'll essentially just say, well, your location is here. There's a bus that goes here, like so. So you should take this bus, and if you want to go to this Waldo. Okay? Okay, so my emulator booted. And my Waldo's number is decal. Seems like it did not connect. That's good. I'll try it one more time. But at least I showed you half of the application. It's just data. So in your phase 1 of the project, phase 1 of the project, you're not going to be dealing with the emulator at all. So this emulator is only useful in the second phase of the project where you're building an interface for Waldo and you're using the map. Because in order to get other Waldos and get a bus to Waldo, you actually need to talk to 2 different services. And what do I mean by that? It means that you're actually communicating over the web. So this is like the internet. Right, so your application is talking over the internet to 2 parties. The first is a Waldo service, which keeps a little database of all the Waldos. And then the second service is TransLink, which also keeps record of all these things. So these are buses. So the first step is to actually build a little piece of this application that just communicates to these 2 services, gets data from them, and then interprets it. Parses this data, but doesn't actually display anything onto the screen. Okay, so I'll just print things out to the console. It's very simple, so it's not going to be as complex as this Waldo thing. Yeah, this thing failed to start. I'll have to give you a second demo. Some other thing. So the first phase of the project, you're going to be parsing data from these other services. Okay? So in particular, you're going to be building up the model classes, you'll be building exceptions, you'll be building tests. So there's a lot of stuff to build because you're virtually building it from scratch. So we give you some code to actually talk to these services, but you're going to have to build the model for representing this data. You'll have to build exceptions for actually checking that things go right. So a big part of this is to actually parse the data. So the data is going to come to you in something called XML format. And so XML format is something that looks like this. So XML is just a representation for data. And it's structured very much like HTML. How many of you know what HTML looks like? Okay. Some of you. So HTML has these tags which delimit data, right? So you have a tag. A tag will look something like O-title. So this is a tag. The reason I know it's a tag is because it's within these brackets. So O-title is a tag. It's an opening tag. And then the closing tag is O-title with a little slash at the front of it. So these are 2 tags. And the stuff in between the tags, this is the actual data. So in the context of this XML format, which describes a Word document, the stuff in the middle actually represents the title of your Word document. Whereas if you had another tag, which was author, then the content would represent the author. So basically XML files have a bunch of these tags, a bunch of this markup. We call all of these tags inaccurate markup. And then the data is represented between the individual tags. So the major part of this first phase is to actually parse XML. So you get a file like this, and you're going to use a library that is going to process it and pull out the things that you care about. So if you're talking to TransLink, it has buses. Buses have, they have numbers, they have certain directions. they have bus stops where they stop. So there's a lot of information associated with buses. So you're going to query translate to get that information about a bus, and then you parse it. And then you'll do the same thing for Waldos. So in the rest of this lecture, we're going to talk about parsing. So you should check out the second project, which is the Sax Parser Example. And I'm going to actually use a modified version of this example, which is missing the parser. So if you open this project, it has the following very simple XML file inside of it, called library.xml. And so this parser example is essentially about parsing XML file that looks like this. The structure of it is, it begins with a tag at the top, which is a library. So you must have a closing tag at the bottom. And then in the middle, it has instances of books. So here's a book. It has a book tag. And the book has a title. And the book has an author. And the book has an ISBN number. Great. So you might have multiple such books. And your books may look, they can be formatted in any way that you want. The key thing is that these tags must appear somewhere, within every book record. And so the point of this application is to say, well, look, there's going to be a library. The library has some number of books. You could add a book to a library. And then there's going to be books. Books are very simple. They have a title and they have an author. Right? Kind of like standard stuff that you saw already. So I'm going to have to create a parser that pulls out this information from the file, creates instances of books, and adds those books to the library. Right, so it's very simple. You're basically creating a little parser that goes to this file and says that, oh, this is a book, so this is going to be the title, this will be the author. So I'll create a new book instance for this block. So if you look at the tests, currently not compiling because they're missing the library parser. So that's what we're going to try to fill in today. So a Sax parser is a particular kind of parser, which is an event-driven parser. So what I'll do here is actually create library parser, and there's going to be another object called an XML reader. And so I use XML reader factory to create this object. But what I'll do next is I call reader.parse of this file in my project. And reader.parse is going to invoke methods on my library parser that I created. So the methods that I add to library parser, I never actually call them myself. They're called by someone else. They're called by this library that does the XML parser. Okay, so let me show you. So first up, this library parser thing doesn't exist. So I need to create a library parser. So let me put this guy inside the parser. So initially, library parser doesn't have anything in it. So one thing we could do. So if I run my test right now, so this thing, this compile. So I need to create a library parser. And I need to give it a constructor. So I'm just going to create a constructor with a library. And I'm not going to do anything. And so if I run this guy right now, yeah. So in order to invoke the methods of this thing, I actually need to make sure that it extends a superclass. That's well known. Let's try to run this thing again. Okay, passes. Wow. Okay, so what is my test doing? It's saying, well, I'm writing information while parsing. I'm in the library, and that's all. So right now, my library parser just doesn't do anything. Empty. So if it attempts to call something, it doesn't exist. So it's silently failing. So the first step in a library parser is to create methods that you want to be triggered when certain events happen. So one of these initial events might be an event like public void start document. And we're going to override this thing. And at the start of the document, I can say something like system app print line starting the document. So if I run the test again, I'll see that this thing was called. But I didn't add a call to it, right? Some other code that is using my class is calling this method. And it's calling this method at the start of every library that I'm parsing. So there's obviously another call, which is end document. So public void end document. And I can do something very similar. Stop reading the document. And so if I rerun my test, I know that this thing is getting called as well. So how do I know which things to override? Well, there's a Java doc page online which describes everything that a default handler does. So we extended the default handler. So the things that we can override are going to be described in the default handler Java doc. So the start document thing receives notification at the beginning of the document. Right? So there's going to be a bunch of these. So every time we parse an element, we're actually going to execute the start element routine. So this is receiving notification of the fact that you've parsed an element within the XML file. So I'll just take this whole thing, copy the signature, I'm going to add it in here. It returns void, and I'll just say, do I have to import something? Here I can say processing element, or maybe started element name. So I run my test. And here are all the elements that I'm starting on. So now I'm running the parser, it's calling start element on the library, then the book, then the title, then the author, then the second book, title, author, right? All of these. You can see where I'm going with this. So obviously there's going to be an end element as well. End element signature looks like this. So I'll add this method as well. And do something very similar. Well, I'll say print line ended element. So if I run my test now, I see that I started element library, then I went and started book, started element title, then I ended reading element title. So this parallels very much the library XML file that we have. At the very top, there's a library. Then below it, there's a book, a title, an author, and then the title ends, and then the author ends, and then the book ends. Right, so this just parsed the first book. So one way of thinking about this file is that I'm registering events that I would like to know about that occur as you parse the XML file. Okay, so the events that I have here are just about starting elements and ending elements. So the final thing we need to add is a method called characters. So start element, end element tells me when it's reading a tag, beginning of a tag and the end of a tag in an XML file. But characters is actually going to tell me when it's reading data. And so I'm going to add this guy here. And when it's reading data, I want to accumulate it. So what I'll do is actually create an accumulator object in my library parser. And it's going to be a string buffer, because that's what we use to sort of maintain strings that may expand. That's going to be my field. So whenever I read my characters, I'll do accumulator.append, and I'll append exactly this character array starting up. So I'm accumulating stuff. And let's say after I end the element, I can actually print the contents of this accumulated buffer. So if I print out what my string buffer looks like now, I can say buffer looks like so now every time I end reading an element, it's going to print out the set of data that I read. And my output now looks much longer. So I read library, book, title. So I ended reading title. So now my buffer looks like this long thing, where I have the House of Hades as the title. And I started reading the author. And I ended reading the author, so now my buffer looks like this thing, where it's concatenated the name of the book along with the author name. Right, so it's an accumulator. It just accumulates everything that you read in between those tags. But of course, I needed to actually read the specific things. So I also need to clear my accumulator. So every time I end an element, I want to print out the accumulator, but then after this, I actually want to set the length of my buffer to be 0. So what this will do is actually create a much more manageable output. After I finish reading the title, here's my accumulator. After I finish reading the author, here's my accumulator. After we finish reading the next book, the title is going to be the next title. Right? So I'm responding to these events, and I'm figuring out how to handle them. So currently on elements, I'm just printing out the element name. And then on characters, I'm building up this accumulator object. So let's set this accumulator to 0 at the beginning as well. And now we can actually start to think about parsing out the title and the author. So for this, I actually need something like string title, string author as fields. So these will maintain my current title, my current author that I parsed out. So when I start reading an element, I can say if my Q name, and I'm actually going to convert it to lowercase first, and then check if it equals title. And I'll say, okay, title now is going to be null. I'm going to reset it at the start of an element. And at the end of the element, if my Q name is title, then I'll actually set the title to my accumulator value. I'll have to put this in the bottom. So I just accumulated a title, so I remember the title. And I can do the same thing with the author. So my book, my library XML has a title and it has an author. So I'm going to say, well, if you read an author tag instead, then I'll reset it at the very beginning. And if I'm finished reading an author tag here, I'm going to set it to my accumulator. So I'm building up the data structure in order for me to actually create a book. Right? And finally, what I want is if my tag that I read here is going to be a book at the very end, then I want to create my actual book with the title and the author. So in this guy, I'm going to say book B equals new book, and my book needs a title and an author. So in my library parser, I'm going to say create this book with the title that I parsed out and the author that I parsed out. So import book from my model. So now my parser reads title, reads author. It gets to the end of my book tag. It creates a book instance. Then starts reading the next book. Reads title, reads author. Gets to the end of the book. Lock creates the second book. Right, so right now, my parser doesn't do anything with these books, it just throws them away. So what I need is something like a library to actually add them. So this guy, conveniently enough, is initialized with a library. So I need to keep a library locally as well. So I'll say this.lib equals L. And then every time I parse a book, I'm going to say library.addBook B. Right, so now I parse the book, I add it to my library, I parse the next book, I add it to my library. And then maybe at the very end, when I'm at the end of the document, I'll actually just say library is, and I'll convert it to string. Everyone with the test now? So library is this beautiful expression. It didn't have anything in it, right? So the toString method doesn't actually print out the library. But what my library contains are those two books that I just parsed out. Okay, so we'll go over this example again next class.